Okay, and let's go. So, we're actually going to do some math today. Shouldn't be too complicated. But I was just like walking by classrooms and I realized some classes they're already showing movies. The first and second day they're always just, it'd be great to teach a class like that. Like one semester I'm just going to say, I want to teach the history of math, and then I'll just show a documentary the whole time. That's awesome. Anyway, I actually have to write stuff on the board, so let's do that. We're going to start with the financial math part. And today we are going to keep it simple. Pun intended, because we're going to talk about simple interest amongst other things. So our discussion will start with interest. You should be interested in interest. It's a very important thing, and it affects more of your life than you probably realize. What is interest? Let's start with that. Yeah?
Money that add up to your principal.
Money that
Add up to your principal.
it doesn't add up to your principal, really. Yeah.
It's a rate that gets compounded to a starting, amount.
It's not necessarily compounded. We'll talk about compound interest separately. But okay, so let's start with it. This is a fee charged by a lender when loaning money. That's how we're going to talk about interest. Okay, it's a fee someone charges you so that you can borrow their money. Okay. Now, the original amount of money borrowed is called, that's what's called the principal. So you borrow some money, this amount is just called the principal for whatever reason. I never actually looked into the etymology. But when someone lends you this money, they will charge you a fee for loaning out their money, because otherwise they might have use for their own money that now they're not going to be able to use it. They want some payback. Any fee that they charge you, it's called interest. Now, typically interest is charged based on some percentage value of the principal. And this is called the rate, the interest rate. And even more typically, they will tell you the interest rate in terms of the percentage they're going to charge you on an annual basis per year. Typically, this is based on an annual time interval and is called the annual interest rate, or APR for short. So someone can say, we're going to loan you this money and I'm going to charge you 5% APR. Basically what they're telling you is that after every year I'm going to hit you with a 5% fee for borrowing my money. Okay? So you borrow some money, this is called principal. Someone charges you a fee for borrowing that money, that is called interest. It is usually represented as a percentage of the money that you borrowed, and that's called the interest rate. Whenever it's based on an annual time interval, they're lending you monies and they're thinking in time intervals of years, it is called APR. So these should all be familiar terms to you, but now we need to know specifically what they are. That's going to be important. Now, there are three major types of interest, and we're going to talk about them. So let's start with the first kind. This is called simple interest. And what's simple interest? How does simple interest work?
Is it just a percentage?
It's what?
Is it just like a percentage? I don't know.
Yeah, but interest is always a percentage. What makes it simple interest? Yeah.
It's always the same amount that's charged to the principal, no matter how much more I
Right. So the interest is charged solely based on the principal and of course the time that you have it out. And the length of time you're borrowing the money for. This is called the loan term, typically. Okay. But I thought interest was always charged on the principal. There's a difference with compound interest, which we'll get to. So simple interest, they charge you interest based on only the principal and the amount of time you're borrowing the money for. So this leads to the fact that if I here is simple interest, we can figure out the interest that you're being charged by taking the P, which is your principal, that's the amount of money you borrowed, multiplying that by R, which is the interest rate, and that gives you a percentage of the principal, but then they charge you that amount every unit of time. So we get PRT, and that's the formula that gives you the simple interest on a loan of size P. Now, the amount A that you must pay back is therefore going to be so at the end of this term of borrowing the money, what are you going to have to pay back? Well, you're going to have to pay back the original amount you borrowed plus the interest. So this was the original amount plus the interest. And so that leaves us with in general, that A is equal to, we can factor out a P because it's a common term, and we get this equation. This is called the simple interest formula. And this is for what we call the future value. I'll talk about that a little bit in probably the next section. Sometimes P is called the present value, and we abbreviate that PV as the notation, and A is called the future value, which we abbreviate FV. But I'll use that when we get to the next section. Okay? So that's how simple interest is charged. Let's just do an example to make sure that we fully understand how this equation is going to work out. So, example. You borrow, let's say you borrow $1,000 at 9.5% APR. And let's say you borrowed with no prepayment penalty. There are times when if you pay off a loan early, someone might hit you with a fee for paying it off early, believe it or not, and that's because they lose out on some of the interest that they would have. But let's say that's not an issue here. You can pay this loan off early if you want to. Okay, so now, if simple interest is charged, how much would it cost you pay off the loan in, say, let's look at a 9-month term. Versus 1 year. It's a very simple example there. Pun intended again, of course. So simple interest, it's only based on the amount of money you borrowed. In this case, you're borrowing $1,000, right? They're charging you 9.5% APR. How much is it going to cost you if you want to pay that money off in 9 months? So, how do you think you do that? Yeah? Did you have your hand up?
Yeah.
Yeah.
Would it be 1,000 times 1 plus 0.095 times 3 over 4 per A?
Yeah. So here you realize the P is 1,000. You realize the R is 0.095 because if we're going to plug this in, we write it as a decimal. And of course, percent means divide by 100, so you just move the decimal point 2 places to the right, to the left. The time is, again, it's charged as an APR, so we have to think of time in years. 9 months is 3/4 of a year, so this is 3 over 4, or 0.75. And so this means that your A is equal to P times 1 plus RT, which is going to be 1,000 times 1 plus 0.095 times 0.75. What's that? Approximately. Yeah?
$1,001.25.
And what?
25 cents.
So that's how much you'd have to pay back if you want to pay this one off in 9 months. So you borrow $1,000, you end up having to pay back $71.25 more than that if this is your interest rate and simple interest is being charged. Okay, let's do B. So in B it's very similar. We again have that R is 0.095. T here is 1, it's 1 year. And so this means that your A is going to be P times 1 plus RT. Whenever we learn a new formula, you want to help yourself memorize it. Pretty much write it down every time you're going to use it. Eventually you'll have it memorized. So 1,000, 1 plus 0.095 times 1. And that's going to give you what? 1,095?
Yep.
So now you have to pay back $95 more if you wait until the end of the year. And this is a loan that's charged, where interest is charged based on a simple interest model. Any questions so far? Okay. Now again, this isn't just something, oh, what's simple interest? It's that thing that Jhevon told us about first day of class. No, this actually affects your life. There are many things that still run on the simple interest model. Car loans, for example, typically run on a simple interest model, right? So if you want to go out and take a car loan, unless you go to some really nefarious car dealership, they're going to charge you based on simple interest. So that allows you to plan for the future, how much it's going to cost you, how much is that car going to cost you over its sticker price. Let's actually compare this to where that was mentioned before, compounded interest. Compound interest. What makes this different from simple interest? How is this model set up? Yeah?
So compound interest is when if the percent you pay is different depending on how much money is added. Like okay. So with simple interest, it's always on the principal, and with compound interest, it's on the amount that you then gets raised. So they would be on 1,095.
Yeah, that's pretty correct?
It's like,
Say it more
it's
concise.
not just on principal anymore, it's
Yeah.
like on principal plus the interest of the previous time.
Okay, yeah, so that's how I would describe it succinctly. It's when your interest is charged based on the principal and accrued interest over some sort of time interval. I'm actually going to write this out, what it would look like. This is when interest is charged. Based on principal and accrued interest. Over some determined time interval. So here is, not only are you being charged a fee on the original amount you borrow, but every time interest gets added to this amount, they charge you a fee on the interest. So interest gets charged on top of interest as well as the original amount, so that's called compound interest because you're compounding the interest. Now, let's just talk about these time, that shouldn't be time interest, time interval. Let's talk about some typical time intervals before we actually get into an example here. So there are some phrases that we might use to talk about the time intervals. So, number of times interest is compounded or charged. Okay, so we have the phrase annual, and that we kind of know it's compounded one time per year. There's also a phrase that says semi-annual. What does that mean? How many times per year?
Twice.
2 times per year, or every 6 months you get hit with interest. We also have quarterly. How many times per year do you think? 4, or every 3 months. We also have, of course, monthly. That means every month. That means 12 times. We have weekly. There are 52 weeks in a year. That's the standard number used. It's not exact, but whatever. That's the standard. And daily, which means 365 times per year. So whenever someone is going to charge you compound interest, there's one more piece of information they need to give you. They have to tell you the APR at which they're going to charge you, and then they have to tell you the time interval. So they're going to say, I'm going to charge you 5% APR quarterly. And that means they're thinking about compound interest, and that actually makes things a lot different. Let's actually, for the sake of comparison, let's go back to the previous example, keep the APR, and let's figure out how compound interest would look on this guy. Now, over the year span, the compound interest is going to look exactly like the simple interest, so let's do one of these other time intervals so we can compare, maybe quarterly. So again, you borrow $1,000 at 9.5% APR. How much would you owe after 1 year if interest is compounded quarterly? And I'm going to actually write out the first example so you can kind of see how the mechanism works, and then I'm going to give you a nice little formula for it. Can you find a nice formula for this? Or I should just say find a formula for this process. Yes, we can. So let's look at that situation. So with simple interest, after a year, we realized that we were going to owe $1,095. Let's see how compound interest is going to look. If interest is hitting us 4 times a year or every 3 months, and then we're charged interest on top of interest, right? So you have the original amount you borrowed, they hit you with interest after 3 months, and then they pretend that's the amount you borrowed and they hit you with interest on top of that. They take a percentage of that new value. And then they pretend that's the new value and they charge you interest on top of that. So they're charging you the same percentage, but the percentage is getting bigger over time. And one thing I want you to realize is that and let's put that in another column, not yet. Just something to be aware of. When compounding, interest is actually charged in installments, right? So it's not like you're getting hit with the entire 9.5% every 3 months. What they do is they split that 9.5% into 4 equal pieces that given by the APR divided by the time intervals. So they're going to take that 9.5%, they're going to slice it into 4, so the interest rate that they're hitting you with every 3 months is going to be 9.5 divided by 4. Let's actually see what this looks like when it all plays out. So, P starts out as $1,000. Now, after 3 months, right, which is a quarter, what's going to be the amount owed? Well, your A is now going to be $1,000 times, well, the original plus the interest rate, which here we're doing 0.095 over 4. Right? So they hit you with a quarter of the interest rate after 3 months. Let's say after another 3 months pass. So this is after 6 months. What's going to happen? Well, now the amount you owe is they're going to take that new amount, not the original, and they're going to charge you the interest on top of that. So you have to pay back that amount plus interest on top of the amount plus the interest before. This, of course, ends up being, remember a little algebra here, you get 0.095 over 4 squared. 9 months pass. Now the amount is, they're going to take this as the new principal, 1,000. 1 plus 0.095 over 4 squared. They're going to hit you with that plus interest again. Of course, that now simplifies to 1 plus 0.095 over 4 cubed. And then after 1 year, they hit you again. They pretend that this is the new principal, as if that was the amount you borrowed, even though it wasn't, and they hit you again. So after 1 year, now the amount you owe is going to be this amount. And you have to pay back that plus interest on it. And that ends up being 1,000. 1 plus 0.095 over 4 to the 4th power. Now, what is that roughly? Actually, plug that in your calculator. And let me remind you now that you need PEMDAS here. So the order of operations matter. Work out what's in the parentheses first, then exponentiate, then you would multiply. funny how they always have those math problems. Oh, this math problem divided the internet. It's usually this really simple thing where it's because people forgot how PEMDAS works. Everyone's, no, the answer is 5. No, it's 33. You know, no one knows how to solve this problem. No, it's usually like a PEMDAS thing. It's really funny. Yeah, if you ever get in an argument with your friends, you can remember the order of these two actually doesn't always follow PEMDAS. If both multiplication and division occur, you read it left to right. So if the division sign actually comes first, you do that first, not the multiplication. So that's the convention. Everyone thinks you always do multiplication first, but that's not how it works. M and D and A and S have the same priority. So if both occur, you apply them from left to right. And then everyone's like, no, this is the answer, no, this is the answer. Yeah, that's usually the trick. So what you want to do here is you want to take 1 plus this, or if you want to be super safe, take this divided by 4 first, because D would become before A. Add 1, get an answer, raise that to the 4th, get an answer, then multiply by 1,000. What would you get here? Yeah.
1,437.66 cents.
1,000 what?
For 437.
Is that work?
I got 1,098.44 cents.
Oh yeah,
That's
I
what I
Yeah, I agree.
forgot to divide.
You forgot to do what?
I forgot to divide the .095.
Oh, yeah, that's important. I'm like, that's a lot even for this silly example. 1,098 seems more reasonable. How many cents?
44.
44 cents. So this lender actually squeezed an extra $3 out of it. $3.44. Now I understand that doesn't sound like a big deal now, but it is an extremely big deal. So oftentimes you guys hear about people getting in trouble, like in credit card debt or whatever, and you're like, how did they get there? Like, what do you mean you have like $50,000 in credit card debt? Well, how they got there is very slowly. You see, it kind of starts out like this. Oh, it's just $3 extra. It's not a big deal. But compound interest is really amazing. They say Einstein said it's one of the 8 wonders of the world or something like that. I don't know if he actually said that, but people always say he says that, and it's really true. It's remarkable how compound interest works. One of the reasons why, let's actually do a little bit of comparison here. Oh, let's actually finish the problem. Let's find the formula, then I'll actually talk a little bit about compound interest and how it might defy expectations. So, formula. What do you think? So, ultimately, the answer looked like 1,000, 1 plus 0.095 over 4 raised to the 4th power. Now, what are the pieces here? So the 1,000 was the P, right? So that was the original principal. And this here, the 0.95, of course, that's the APR. This here was your time interval, or the number of times it's compounded per year. We'll call this N. This here, the APR, we'll call it R, like we were before. How would you describe this 4? What's that 4 representing? Yeah.
The amount of times it's charged.
The number of times interest was charged. Number of times interest was charged. So over 1 year, we were hit with interest 4 times. How many times would we have been hit with interest if we borrowed this for 2 years? 8. And so how do you think this 4 is going to work out? What formula could I use for that part? Yeah.
You can use T times.
Well, it's not just T, right? The 4 can't be T because T would be 1. Yeah.
N times T?
It's N times T. You see, there's an invisible 1 here for the year, and it's 4 times per year. So this ends up being N times T. So ultimately, we end up with the formula A equals P 1 plus R over N to the N times T. And this is the compound interest formula. So if I give you a problem, okay, here you're borrowing some amount of money, that is going to be the P. I'll tell you, here's the APR, you're going to put that number over here after converting it to a decimal, and I'll tell you it's compounded weekly, and that will affect the end value, so you'll put n equals 52. Or if I said annually, n equals 1. Or if I said quarterly, n equals 4. And then T is going to be the loan term, or how long you're borrowing that money for. Plug that into this formula, that gives you the situation that would happen had you compounded the interest. Now in this situation, after compounding it quarterly, we managed to squeeze an extra $3.44. And I mean, you're borrowed $1,000. Comparatively, $3 doesn't seem like a big deal. Here's why it's a big deal. Did everyone get this? I'm going to erase up to that formula. Now, this is a big deal. Even though it might not seem like it in the beginning. Here's why. Now, when you're looking at simple interest, let's say you're plotting how much you owe over time. It turns out that if time is my variable here, simple interest kind of looks like a straight line. In fact, it looks like y equals mx plus b, right? So you would have here, the amount you owe is going to be PRT plus the original P, right? Now, what this looks like, you might notice it looks like a straight line. This is like your M, this is like your X, this is like the B. So it actually would grow as a straight line. So if you're thinking of simple interest, that's how it's going to grow, right? So that's how much the amount of money you're making grows. Now versus compound interest, notice where the X is. The X is actually in a power. The X is not just being multiplied on the base. Now that means, so this means simple interest, it gives rise to a linear function. Hopefully you remember what a function is. Compound interest. This gives rise to what we call an exponential function. This guy is going to look like that. Right? So that's how the amount you owe over time is going to look on a graph. And still, me drawing these two pictures still probably doesn't give you the actual idea of what's going on. So here's a better reality of the situation. And those of you, well, pretty much all of you, you're going to do calculus right after this class. In calculus, you're going to really start to appreciate the difference between linear functions and exponential functions. But here, let me actually draw a scaled picture to give you an idea. So let's say now we're not looking in the short term. Forget over 1 year. Let's a very large time interval. Okay, so let's zoom out and let's not look at the next 1 year or 5 years. Looking at the next 30 years, next 40 years, next 60 years. Okay, what is your compound interest going to look like? Well, it's like an exponential. It's going to look like this. Now, by comparison, what would your simple interest look like on a very large time interval? It turns out it's actually going to look like this comparatively. It's almost going to look like it's not even moving. Eventually, compound interest starts to pull away from simple interest at an unbelievable rate. Now in the short term, you're not going to notice this happening. It's an extra $3, extra $10, extra $100, it doesn't matter. Eventually, the gap starts to begin to widen at an unbelievable rate. Now when you talk about limits in Calc 1, you're going to start to see that effectively if you get large enough, this guy might as well not even be trying. He might as well be zero. He's going to be nothing compared to the exponential, right? So eventually, the exponential keeps pulling away, right? And it pulls away more and more. The longer you go, the more it's going to pull away by, right? This guy's always increasing by a fixed amount. This guy doesn't increase by a fixed amount. The farther you go, the higher he increases by. Right? So that's why, in this example, an extra $3, what's the big deal? It's a huge deal. And that's how a lot of people get in trouble. They don't realize that that's going to happen. Right? And I don't really watch Shark Tank, but I've seen a few episodes, and sometimes I see them like, they're bargaining when they like someone, the deal that someone offers. And they're like, okay, I'll give you 8% stake. And the guy's like, how about 8.25%? And then it's like, no deal! And I feel like people who don't realize how compound interest works, they're like, what's the difference? Just give them the 0.25%. Over time, it makes a huge deal, and business savvy people are going to know this. But the people who are not business savvy, they immediately lose negotiation power because they don't realize what they're negotiating, right? So I want you to appreciate, over time, with compound interest, it really pulls away. There's actually a huge difference. In the short term, unnoticeable, or barely noticeable. In the long term, though, you'd be amazed. So this is why someone can have a job that pays modestly and just contribute to their 401k, and then they retire a millionaire. How does that happen? Compound interest is how it happens. Okay? So when you're investing money, for example, it's almost like you're the lender. And the rate of return on your investment is kind of like the interest that's paid to you, and it gets compounded. And that's how this thing can turn a very lowly guy into a millionaire, but it'll take a long time, of course. But I just want you to appreciate these two things are very different. And sometimes in the time interval we're looking, it's not going to look that different, but it's very different. Okay. Let's actually talk about another real world example. Every time math class, people go, what does this mean in real life? So let's just mention a couple. So like I said, car loans, typically simple interest. What do you know that's typically compound interest? I'll tell you one, credit cards. So credit card debt is of course a compounding interest debt. Another thing that might be compounded, student loans are actually compounded, right? So it might seem like all fun and games now. Oh, you just have to pay this back when I graduate. Don't leave it for too long, you will get in trouble.
Bank loans?
Huh?
Bank loans?
Bank loans are often compound interested, and that would come under credit cards as well. For sure, private student loans are compounded. I'm not sure how the federal one works, but these are some examples. Let's actually do another comparison, right? Let's take a typical credit card interest situation. Let's say you're hitting somewhere like 20%, right? Which isn't crazy. If you don't have a long credit history, your credit card interest rate is going to be about 20% compounded. How often are credit cards compounded? Huh? Monthly, yeah. You pay your bill every month, so that would make sense, but no. Imagine someone really wants to take your money. It's daily. Credit cards are compounded every single day. Okay? That's how it sneaks up on you. And again, you don't notice this the first month or the second month or the third month. But just doing quarterly, we pulled away by $3. Let's actually do an example. Let's say, again, $1,000. Let's say R equals 20%. And let's look at 5 years. And let's do simple interest let's do it simple interest versus the compound interest. Now, how much would you owe at the end of 5 years if you're not paying any payments in the interim? Well, bar 1,000, it's going to be 1 plus 0.2 365, right? That'll give you what? That's 2,000, right? So okay, so over a 5-year span, you'll have to pay back double what you borrowed at this high interest rate. So really crazy high interest rate. What about now compounded daily? What's that going to look like? Well, we can use the compound interest formula. Over 365, and in the power we now have 365 times 5. Now what's that going to look like? Now remember PEMDAS, this divided by that, then add 1, then put that little caret thing to raise to the power, open parentheses, put this times that, close parentheses, multiply 1,000. What's that going to look like over a 5-year span? 2,717. So here you pay back double. Here you're paying back almost triple. Okay. Let's actually do another time interval. Let's stretch this a little bit. Right. So now it's not $3 anymore. Right. Now it's kind of, that's a decent chunk of change. Okay, 700. Okay, let's move to 10 years. What's going to happen? Simple interest. Let's look at compounded daily. Same P and interest rate. So here our A is going to be 1,000. 1 plus 0.2 times 10. Yeah. 3,000. Okay, you're netting an extra $1,000 a year, and that's not changing. It's growing by a linear. It's always going to increase by $1,000 every year. That hits you at 3,000. What if it's compounded daily? 0.2 divided by 365 raised to 365 times 10.
So 785.
What?
785.
Starting to become significant, isn't it? Right? You're paying back triple. Now before, it's like we were barely paying back one extra principal. Now we're almost doubling what we have to pay back. We're paying back 7 times more than we borrowed compared to 3 times more than we borrowed. Compound interest is going to start pulling away crazy fast. This guy's increasing by $1,000 a year. That guy's going to increase by more and more every year. You start stretching out to 15 years, 20 years, right? 30 years, 60 years. You are going to have a decent chunk of change here. Yeah.
So are you paying that 7,300 in a single year or over?
Over the course of the year. Right.
Oh.
So let's say you forgot about the loan and then you came back 10 years later. I just want to pay you back what I owe you. They're going to hit you with a $77,000 bill. Right. There are situations where you can pay while it's growing, and we'll deal with that later. But yeah, I just want you to understand how this simple versus compound interest, it's a big deal. And knowing what situation you're in, are you charging me simple interest or compound interest? Makes a huge deal in how you're going to plan out the next few years of your life. Right? It's a big, big deal. And these things are happening in everyday real world situations. And if you don't know what situation you're walking in or what it's going to mean for you, you're going to be in trouble. We'll pick up next time on Tuesday. Enjoy your weekend. No, not homework yet. But I'll email you guys when it's up.